So, what is a break-even analysis and how does it help anyone trying to develop a product? Well, simply put, a break-even analysis consists of calculating how many units of a product you need to sell at a given price to cover all your costs. In other words, it tells you how many units you need to sell to have a profit of 0, that is, to break even. If you sell one more unit, you start making a profit. So the first thing we must do in order to perform a break-even analysis is to make sure we understand our cost structure. And if you don't know what I'm talking about, you can watch the video that I'm linking about it below. Because our goal here is to analyze how our costs and profits vary depending on our production and sales volume. That is, we need to perform what is usually referred to as a cost volume profit analysis, or CVP. And to do that, it's obviously fundamental that first we understand how our costs change as our production volume changes. Anyway, to illustrate all these concepts that might be a bit confusing, let's use the bakery example you may already be familiar with if you saw the cost structure or the contribution margin videos. In this case, let's imagine that we're making birthday cakes, which we sell for $50 each. Making each of those cakes has a total variable cost of $15. That's for ingredients, packaging, electricity to bake it, etc. And we have total fixed costs of $5,000 per month. That's for salaries, rent, equipment depreciation, etc. Now, as we've seen in the video about the cost structure, variable costs increase with each additional unit of product you manufacture, while fixed costs remain constant despite variations in production amount. In the case of our example, whenever we make an additional cake, our variable costs increase by $15. If we bake one cake, our total variable costs are $15. If we bake 2 cakes, $30. If we bake 10, $150, and so on. So, they can be represented graphically by an upward sloped line. And we can calculate our total variable costs of producing birthday cakes, let's say for a month, by multiplying the number of cakes we produce per month by the $15 of variable cost per unit that we have with each of those cakes that we make. Note that sometimes as production volume increases, the variable costs per unit decrease. That's because we start getting quantity discounts or economies of scale. That's not being considered for simplicity reasons, but in real life you might want to. Now, when it comes to fixed costs, because they're fixed, regardless of the number of cakes we produce, we'll always have a cost per month of $5,000. So they can be represented by a horizontal line. So to get to our total cost per month of producing birthday cakes, we need to add the total variable cost per month and the total fixed cost per month. Graphically, we would get a line with the same slope as the variable costs 1, but instead of starting at a cost of 0, it starts at the level of fixed costs that we have. Basically, the variable costs line shifts upwards by the amount of fixed costs per month. If you prefer to see it mathematically, we would add our total variable costs that we've seen before to the total fixed costs per month of $5,000. And that's it for the cost part. By now, we know how our costs change as our production volume changes. So if we want to calculate at what production volume we break even and above which we start making a profit, we need to calculate how our revenue increases with each sale. But that's the easy one, right? If we sell each birthday cake for $50, it's obvious that our revenue increases by $50 whenever we sell a cake. If we represented our revenue graphically, we would get a similar line to the variable costs one, but steeper. Since the price at which we sell each unit of our product is higher than what it costs us to make it, when we multiply it by the number of units sold, total revenue grows faster than total costs. Note, though, that there are a couple of important simplifications here. One is that our selling price remains constant regardless of how many units we sell. And the other, and the most important one, is that we're assuming that we sell every unit we produce. If that's not the case, to avoid this assumption, we would have to factor in the cost of the wasted resources on our total costs. Anyway, moving on, since the total cost and total revenue lines have different slopes, if we represent them in the same graphic, they will intersect. After all, costs start at a higher level, but because revenues go faster than costs, at some point total revenue will surpass total costs. At that point at which total costs and total revenues are equal is what we call break-even point. To the left of that point, our business is running at a loss. To the right of it, revenues are higher than costs, and you're making a profit. So, at the break-even point, your sales and your costs are the same. And we know that total sales equals price per unit times number of units sold. Total costs equals variable cost per unit times number of units sold plus fixed costs. This means that our profit will be zero when both sides are equal. Since we're assuming that the number of cakes made and the number of cakes sold is the same, I'll replace it for Q to represent quantity and make it shorter. So, if we solve this equation, we get to the conclusion that we need to sell 143 cakes every month for $50 each to break even. Above that, we start making a profit. And this is one of the reasons why the cost-volume profit analysis is such a great tool. Since we know that profit is equal to total revenue minus total cost, we can get to an equation that allows us to calculate how many units we would have to produce and sell to cover our costs. You see, it may be very difficult to estimate how many units of a product you will sell, but if you want to turn that question into, is it feasible to sell X units of my product at a price of Y, it becomes a lot easier to answer. And if the answer to that question is no, you have a problem, but at least you know it and can take measures to solve it. So one of the points of this analysis is to help us understanding whether it is realistic to expect to make a profit if we sell at a given price. Anyway, if we simplify that equation further, we see that our profit is equal to selling price minus variable cost per unit, also known as contribution margin, times the number of units sold minus total fixed costs. Since we know our costs, we can use this simple equation to build scenarios considering different target profits, target sales price, and target sales volume scenarios and how they affect each other. And this is what's great about a break-even or cost-volume profit analysis, and the reason I use it for anything I do. It not only turns the difficult to answer question, what is my expected sales volume, into a much easier to answer, is it reasonable to achieve this particular sales volume, but it also allows us to create different scenarios of expected prices, costs, and required unit sales to reach a target profit, and help us therefore understanding the impact of our possible decisions. And that's it for the break-even and cost-volume profit analysis. I hope you liked the video. In my next video, I'll go over the impact of discounts on profit, particularly about how seemingly small discounts can get you in the red if you fail to make an important calculation I'll explain. So if you're considering offering discounts or even cutting our prices, I would encourage you to watch that one. So, see you in my next video. Bye!